Okay, Algebra 1, Section 6.2, Substitution. The next section in System of Equations. So if you remember 6.1, we talked about graphing solutions, and where they intersected was the solution, where the two graphs intersected. Well, you don't have to graph them. There are other strategies. So one of the other strategies here is substitution, which we're going to do today. So we're going to solve a system of equations using substitution. So again, system of equations, it's two or more equations. And then substitution is another method to find a solution to a system. So remember, it goes back to when you graph them, you could find that point where they intersected, and that would be your solution. Well, you can find that point another way using algebra. And so substitution is what we're going to do today. So there's method, another strategy. So to solve using substitution, we're going to solve one equation for a variable. So we've done that before. So you've got, let's say you had something like x minus 2y equals 8. Well, if we wanted to solve for x, then you would just basically add 2y to both sides, and then we'd have x equals 2y plus 8. So in that case, we would solve for x in that situation. If we were to solve for x, that's what we're trying to do, is isolate x. And you could do it for y as well, but that's kind of what we're looking at doing. So that's what you would do first. Then you're going to substitute that value into the second equation. So like I said, there's two or more equations. So whatever you got for x, you're going to take that whole thing and substitute it in for x in the second equation, and then you're going to solve for that one. So you're going to find the value of the other variable. So you plug it in, and you're going to solve for the value. And then, so you kind of do like a double substitution in here, and then you put your answer in an ordered pair. All right, so we'll show you a couple examples. I know it looks like a lot right now, but once you get it rolling, it's really not too bad. So let's take a look at an example of that one. Use substitution to solve this system of equations. Well, the first thing I'm going to look for is there a variable that's already isolated, that's already by itself? And yes, there is. Right here, this y equals, it's already there by itself. So there's no need to rework the equation and solve for y, because it's already been solved for. So now what we're going to try to do is we're going to take that, we're going to take this 3x, because y is equal to 3x, and we're actually going to substitute it in for this y here. Okay, substitute it in there. That's called the substitution part. So we're going to take that x, where it was x plus 2 times y equals negative 21. Now we're basically getting rid of that y and saying, no, it's not y anymore. Y is equal to the 3x. So x plus 2 times 3x. And now we're going to solve for the variable. We're going to solve for x. So if we do that, now we're going to say x, and then we've got 2 times 3x is 6x equals a negative 21. From there, we can solve. I can combine these two to make a 7x, combining like terms, and then it equals a negative 21. And I divide by 7, and I've got my x to be negative 3. Okay, so now that I know what the x is, I can plug it back in to this equation here. So I'm going to take this equation over here and say y equals 3x to solve for y. And I could use either equation, but this one's pretty easy because it's already in y equals form. So now I'm basically saying I'm going to substitute my x value, which I know is negative 3. I'm going to substitute that in here, so it's a double substitution part. So now I've got y equals 3 times a negative 3, which then y would equal a negative 9. And then the last part said we're going to put our answer as an ordered pair. So we've got our x value and our y value. So our ordered pair would be negative 3, negative 9. And that would be the solution. So if we were to graph these two, that would be the point in which they crossed at negative 3, negative 9. Okay? There's always more practice you can do, so you guys can work on number 2 if you'd like. And now let's talk about infinitely many, because we'll get some more practice with substitution doing these as well. So infinitely many, what we're going to do here is This is one where, hey, we've got to do some things. Do we have any points here where we have a y or an x by itself? No, not necessarily. But we do have one that's close. If we look at this y here, it's really close. I know that if I just divided everything here by 3, then I would have it isolated. So really now it would be y. These cancel out to make y. 6 divided by 3 is 2x. And then we have a negative 6 here. So now I'm really close. So now I've got my y equals. So now I've isolated it. So now I can go ahead and take this 2x minus 6 and substitute it in here for y, because it says y equals 2x minus 6. So again, now I'm going to take that, and I'm going to use the second equation, this 2x minus y. So 2x minus y equals 6. But remember, I'm not actually taking the y. I'm going to use what I substituted in, this 2x minus 6. And I always put it in parentheses because that way I know that this is to remind me to distribute. This would distribute this negative or this negative 1 in here. So now when I go ahead and do this problem, I'm going to have 2x, and I've got negative 1 times 2x is negative 2x, and then negative 1 times a negative 6 makes that a positive 6 equals 6. Okay? Now combining like terms, I can notice that, hey, I've got a 2x and I've got a negative 2x. Those are going to cancel each other out. So now I'm going to be left with 6 equals 6. Well, that's a true statement, right? 6 does equal 6. So this is one of those infinitely many. We've seen them before, where if you end up getting no variables in a true statement, then your answer would be infinitely many solutions. So, and this is the case where our lines, if we graph these, our lines would be right on top of each other. They would be the same line. So they would have infinitely many solutions. So again, the variables cancel out, and you get a true statement. It's going to be infinitely many solutions because it's basically going to be the same line. Okay? And then let's talk about no solution. We kind of get the idea now that after you substitute, your variables are going to cancel out, and then you're going to have a false statement. So let's do one like that. If I take this equation here and solve for my x, it's really close. So all I really have to do is subtract y from each side. Then I would have something like x equals negative y minus 2. Okay, and so that way I could take that x, negative y minus 2, and substitute it way over here into this x right here. So now I'm going to go ahead and use that first equation, 2 times x, but remember, I'm not going to use x. I'm going to use what I substituted in here, negative y minus 2. And again, use the parentheses. That's going to help us to be able to distribute. Plus 2y, just writing this entire equation down, just substituting the value in for x, equals 8. All right, so here, after distributing, negative 2 times y is a negative 2y. And I've got negative 2 times negative 2 is a negative 4. Plus 2y equals 8. Okay, so in this situation, the y's are going to cancel out, as you can see. Positive, when you combine like terms, you got a positive 2y and a negative 2y. Those are going to cancel out, so you're left with negative 4 equals 8. Well, that's not true. That's a false statement. So when you have no variables in a false statement, then we would use no solution. So that was the other chance you could get. So you could have one solution, you could have infinitely many, and you could have no solutions. And here, they would be parallel lines. They would never cross. Okay? So there's always more practice problems you can do, 5 and 6 here, but that's going to be it. We're going to get into the lesson summary. And really what I'm looking for is if you want to do the extra problems, do the extra problems. We'll probably look at them in class as well. But the lesson summary today is, what is one question you have about solving by substitution? What isn't quite clear? So I want you to ask something. I'm going to call on people to ask some questions about what don't you quite get about it. And then your practice problem, you're going to solve this by substitution. And it's nice because you got a nice little y equals there for you. Okay? That's it for substitution. And bring some questions, and we'll be ready to go tomorrow. See you next.